Okay, this is number, I forgot what number it is, but it was one that I didn't do last night. So this is part C where you're finding the limits. I think it must be number 3. Um, yeah, number 3, part C. Okay, there should be a way that he has shown you how to do this algebraically. Um, but I'm not sure what he's wanting you to do. So I'm going to show you how to find the answer in your calculator, and then at least you'll have the answer and you can ask him algebraically what he wants you to do. So I'm going to go ahead and put this in my y equals. So I'm going to hit y equals, clear that out, and then I'm going to use my fraction button again. So I have the square root of x plus 1 minus 2 over 3 minus the square root of 2x plus 3. Okay. Now, I'm just going to graph this in the standard viewing window right now. But what they're wanting to know is, where is this graph approaching when x is getting closer to 3? Well, I do have an answer. Here's when x is 3. I want to know what this y value is. So let's go to our table. Okay, so I'm going to type in some numbers really, really close to 3 coming in from the left-hand side. So like 2.99 and 2.999. Okay, and then I need to type in some numbers coming in from the right of 3, like 3.001 and 3.0001. So do you see that my y values are approaching negative 0.75 or negative 3/4? So that's my answer for part C, negative 0.75, or you could write negative 3/4. Okay, part D, we're going to do the same thing because I'm not sure what he's going to want you to do as far as algebraically. So I'm going to show you what it would look like in the calculator. Put that in my y equals, alpha y equals for my fraction button, the square root of x plus 3 minus 2 over x squared minus 3x plus 2. Okay, again, I can look at the graph, and I want to know what this graph, my y values, what they're approaching as x is getting closer and closer to 1. Well, I'm going to, let's go to our table. So I'm going to type in a number coming into closer to 1, but from the left-hand side. So like 0.99, and then 0.9999. Okay, so it looks like it's approaching from the left-hand side negative 1/4 or negative 0.25, but I also need to check numbers coming in from the right-hand side. So numbers really close to 1 from the right-hand side would be 1.001 and 1.00001. And D, let me see here. I must have typed in this wrong because I think I'm supposed to get no solution on this one. Let me look at my y equals again. X minus 2, x squared minus 3x plus 2. So D, let me look real quick. For some reason earlier I'd written down that there was no answer for this. So coming in from the left of 1, coming in from the right of 1. So do you see that they are approaching a number? Looks like they're approaching, let me type in another one. Yeah, negative 0.25. Okay, so the next one. Okay, I'm going to come back to this one because I haven't figured out exactly what I need to do yet. All right, use the intermediate value theorem to find two different integers such that the equation has a solution x in the interval from n to n plus 1. Prove your answers with simple, easy, verified calculations. So the first thing I would do on this one, here's what the intermediate value theorem says. It says that if I have this interval, okay, and they're saying, hey, this is Trevor calling. I'm going to pause this for a second. Okay, sorry. All right, so the first thing I'm going to do, let's graph this to see what this looks like. because here's what they're saying. This says that find two different integers so that it has a solution between those two integers. So let's graph it. So I'm graphing x to the fourth plus x minus 3. Oh, good grief. X to the fourth, and then plus x minus 3. Okay, and I'm just graphing this in the standard viewing window. All right, so it crosses, I want to know where this crosses between what two numbers. So it crosses between -2 and -1, and then it looks like between 1 and 2. All right, so I'm going to write that down. So I need to check between -2 and -1 and between 1 and 2. All right, so here's what the intermediate value theorem says. Okay, um, find two different integers in such that the equation has a solution. So I'm going to find a solution to this, and the solution is where it crosses the x-axis in the interval between n and n plus 1. Prove your answers with simple, easily verified calculations. So my first one is I'm going to show that this has a solution between -2 and -1. And this applies because n and n plus 1 means whatever number you choose, the next number has to be 1 greater than that, and it is. So now I need to just show where that graph crosses between those two numbers. So I'm going to find this point right here. All right, so it's going to be second trace. I want to know where it crosses the x-axis, so it's going to be number 2. And then it's going to ask you, type in a number to the left of where it crosses. So I'm going to type in -3. And it says, okay, type in a number to the right of where it crosses. So I'm going to type in 0. And then guess where it crosses. I'm going to guess that it crosses at -1.5. And right here is where it tells us where it actually crosses. It crosses at -1.452. Now, here's the problem. It says two different integers. -1.452 is not an integer, so I don't know if he's just wanting these two numbers. So I'm going to type in -1.452 is where it crosses between -2 and -1. And then I'm going to do the same thing here. And he may want you to do this a different way. I don't know what it's kind of hard to know what he wants whenever you're not there. But now I know it crosses between 1 and 2 again. So I'm going to do the same steps. Second trace, number 2. This time type in a number to the left of where it crosses at the second point. So I'm going to type in 0. Type in a number to where it crosses to the right. So I'm going to type in 2. And then 1.5 is my guess. Whoops. Oh, 1.5. So it actually crosses at 1.164. 1.164. So, I don't know exactly what he's wanting, but something like this, but it might give you an idea of what to do. Number 10, find all the horizontal and vertical asymptotes. Okay, vertical asymptotes are easy. We set the denominator equal to 0. Okay, so I'm going to set the denominator equal to 0 and then solve. I can solve this by factoring. I know my signs are the same and they're both minus. Factors of 8, then when I add them I get 9. That's going to be 8 and 1. That should have an x right there. So x minus 1. So when I set each factor equal to 0 and solve, I get x equals 8 and x equals 1 as my vertical asymptotes. My horizontal asymptotes, here's what you do. I have a horizontal asymptote when I look at the degrees of my numerator and denominator, and the degrees would be your highest exponent. So my degree here is 2, my degree here is 2. So when your degrees are the same, you have a horizontal asymptote. And that asymptote is what they call the ratio of the leading coefficients. All that means is your x's with the greatest exponents, this has a 1 in front of it, this has a 1 in front of it. So you take these two numbers, 1 over 1. That's where I have a horizontal asymptote at y equals, 1 over 1, positive 1. And we could always check our answer by graphing it and make sure that those actually look on my graph where the horizontal and vertical asymptotes are. So just to show you that it works, I'm going to graph that. I have x squared minus x on top, x squared minus 9x plus 8 on bottom. I'm going to graph that in my standard viewing window. Let's see here, y equals x squared minus factors of 8, and x equals 1. Oh, you know what? I need to fix something. Before I do this, okay, I almost messed up. I need to factor the top. I can factor the top like this, factor the bottom as this. All right, I'm glad, and here's how I knew I was wrong, because look at my graph. I was showing that I should have a vertical asymptote at x equals 8 and x equals 1. Well, I do at 8, but it wasn't showing the 1 at 1. And here's why. Always factor first. So my top will factor to this, my bottom will factor to this. I have common factors. Where you have common factors, those will cancel. And now that's just where I have a hole in my graph. So my only vertical asymptote is actually at x equals 8. Okay, and then I do, if you'll look at your graph, I still have a horizontal asymptote at 1 because it flattens out. But always factor first, cancel anything out. Whatever cancels, that's where you have a hole in your graph. And so now I only have one vertical asymptote at x equals 8. Okay, number 11. Number 11, sketch a graph of a function satisfying all of the following. All right, so here's what I do. And this is just kind of a guess and check type thing. I'm going to go ahead and draw my XY axis. All right, first thing I always do is I look at any ordered pairs that they give me. This right here is just the point -4, 0. So I know 1, 2, 3, 4. And then this is also a point that they give me, 3, 0. 1, 2, 3. All right. So my point's the first thing I always graph. So I know I have the point -4, 0, and I have the point 3, 0. Okay. Then it says the limit as x approaches negative infinity equals 0. All right. So I know as my graph is going to the left, it's going to approach 0, but it also has to pass through this point. All right, the limit as x approaches 0 equals negative infinity. So as my graph gets closer and closer to 0, it's going to have to go down to negative infinity. So far, and I may have to erase this, but so far, I think if I have something like that, it would work. All right, let's see. The limit as x approaches negative infinity. So as my graph goes to the left, it has to approach 0. Okay, so my graph has to get closer and closer to the 0. It has to pass through the point -4, 0. And as the limit as x approaches 0, so as my graph gets closer and closer to 0, my y values have to go down. This one says the limit as x approaches 6, so 1, 2, 3, 4, 5, 6, as it approaches 6, my graph's going to go up. And then it says the limit as x approaches infinity is going to be 2. So I must, at 6, I must have a vertical asymptote here because, let me show you. So right here, this has to go down because the limit as x approaches 0 from both sides has to go approach negative infinity. It has to go through this point, and the limit as x approaches 6, my y values have to go up. It has to approach positive infinity. So this one says the limit as x approaches infinity, so the right-hand side of my graph, my y values have to approach 2. Okay, so I must have something that looks like that. It's kind of messy. But as x approaches 6 from both sides, it has to go up. That's because of this. And as x approaches infinity, it's going to have to go to 2. Here's 2. So I must have like this kind of horizontal asymptote. So it looks something like that. All right, I'm going to stop it right there and then send another video.